right, here we go. So 7.3, we're going to solve. Okay, so example 1 instructions said solve each equation on the interval inclusive from 0 all the way to non-inclusive at 2 pi. So just normally, what would you do first? Move over the 1, so that would be 2 cosine of 2 theta equals a positive 1. Perfect. What's the next step? Divide both sides by 2. You are correct. So cosine of 2 theta equals to 1/2. What do you think you want to do next?
Take the inverse cosine.
Yeah, totally. Inverse of cosine. So that would totally be 2 theta equals inverse of cosine of 1/2. Now, let's look at the original. Would you agree that the original is a regular trig function? Yeah, that means it doesn't have a restriction. Okay, that means it can have 2 quadrants for positive and 2 quadrants for negative. Now, on the bottom, we are just borrowing the cosine inverse so we can solve. That doesn't mean it started out as an inverse. Okay, so we always look at the original. So what quadrant or what quadrants is cosine positive half in? 1 and
2, 4.
4. Positive cosine, right? Did I say cosine or cotangent? Cosine. Sorry, I don't. So cosine's positive in quad 1 and also in quad 4. What angle in quad 1? Pi over? Okay. And then the other one. Good answer. But let's look at a restriction again. Can I go the negative route this time? No, I want to get to quad 4. So I'm going to go all the way, right? There's no guy at the top. So what's the answer to the other one? 5 pi over 3. Okay. So you would have 2 equations because you have 2 different angles for cosine inverse of a half. So 2 theta equals a positive pi over 3, and 2 theta equals 5 pi over 3. How do we solve for 1 theta? Normally, what do you do next? Divide both sides by 2, or times a half. Okay, because if I times a half, it's slightly quicker for me to multiply. So 1 theta came out to be a pi over 6, and the other side is 5 pi over 6. Now, are we done? Do we box that up? You think we're done? Yeah? How do you know you're done? And how do you know when you're not done? We have to check to see if it's in the limitation, and our limitations, it says 1 theta can only be between 0 and 2 pi. Are we okay?
Yes.
Could there be more?
Yes.
How do you know?
Because we are restricted, and so like there could be. And then like could be like more than one, but because we're restricted, we don't see all.
So right now we have 2 answers. I mean, they're both fine right now. Could there be more? How do you know?
Like if you add it by a certain integer, go around the circle, then it would have more possible.
Okay. So just pay attention. Don't write anything, okay? I'm going to graph this out for all of us. I would try to graph out 2 things here. Oh, well, this equation. Because this is what we started solving. Would you guys agree? You were asked to solve for it from 0 to 2 pi. Again, don't write anything. Just try to understand. And then I'll leave it up for you to write, okay? You were asked to solve that from 0 to 2 pi. So I'm just going to graph it from 0 to 2 pi. I'm going to go up as high as 1, as low as 1. I will graph this in 2 parts. The first side is I'm going to do a half. So half is just this portion right here. So this is y equals a half. Does that make sense so far? Then I'm going to now try to graph cosine of 2 theta. Cosine of 2 theta, what's the period?
Pi.
Yep, so here's a pi. That means I'm going to go here and here, and that means here and here. So cosine at 0, I'm still going to go up at 1. And then because there's a pi period, this is my graph for that, okay? Can you see that's 0 to pi? And we did get how many answers?
2.
2. When you saw by graphing, we're locating where the two curves intersect. Okay? Can you see that those two intersected at 2 different locations? One of it, as you can see, it's at pi over 6, right? And then one of it's right before pi, so we can just assume that's 5 pi over 6. But isn't the question asking you to solve all the way to 2 pi? So technically, should I keep going with this curve?
Yeah.
Yes, I gotta keep going, you know? So if I keep going all the way to 2 pi, how many times do you think these two things intersect?
4.
4. So how many answers do we have total? 4. But how do we get the other 2?
Add pi to each one.
Add a pi to each one. Add another period. Okay, so if we look at our original question, let's find the period right away. What was the period? Period was 2 pi divided by b, right? What's a b value here? 2. That's right. So that's why you get a pi. So I'm going to write 2 pi divided by b. For some of us don't remember, that's 2 pi divided by 2. This is a 2 value in here. Okay, the b is inside. So that is a pi. So you take whatever you solve, and you need to keep adding the period until you cannot add any more. So a pi with denominator of 6, that's kind of like what over what?
6 pi over
6 pi over 6. So if I add 6 pi over 6, the next one would be 7 pi over 6. Would you guys agree? 5 pi over 6 plus a pi, aka 6 over 6 pi, which is now 11 over 6 pi. Can I add any more? No, because if I add more, it will be over my... Yep, that's right. So let's write it from smallest to biggest. Theta is pi over 6, 5 pi over 6, and don't worry, I'll leave it up. 7 pi over 6, and 11 pi over 6. Box that up, and I'll leave that up for you to copy. So don't worry if you didn't have time. So every question, should we start out checking the period right away? Yeah, what's the period for 2? I mean, not 2. 1b, I meant.
2 pi over 3.
Is tangent 2 pi divided by b?
Oh, sorry. Pi over 3. Pi over 3.
That's right. Tangent is 1 pi divided by b. What's your b value here?
3.
3. You're right. We always have to check the period. Okay. So this period, it's 1 pi divided by b, but b is 3. So the period is pi over 3. And we solve it normally. What do you do first? What do you do first? Evan, what do you do first, hon?
Oh, yeah. Subtract 1.
Good job. So we have rad 3 times tangent of 3 theta equals to -1. What do we do next? Emma? Good. Divide both sides by rad 3. So we have tangent of 3 theta equals -1 over rad 3. Do not rationalize. You don't have to because that's not our end result. What do you think we do next? Caitlin M? Perfect. Tangent inverse of a -1 over rad 3. Remember, we're only borrowing tangent inverse to solve, so there is no restriction, okay? We always have to look at the original. Tangent inverse in 2 quads, what are they? Tangent inverse that's negative, I'm sorry. Tangent that's negative in 2 places, what are they?
2 and 4.
2 and 4. Now we have to figure out the angle. What angle in quad 2 will give me a -1 over rad 3?
5 pi over 6.
5 pi over 6, beautiful. And that means angle in quad 4 is?
11 pi over 6.
Yep, so I'm going to go wee all the way there. 11 pi over 6. So how many equations do we now have to set up? 2. 3 theta equals 5 pi over 6. And then 3 theta equals 11 pi over 6. How do we get rid of, Sophia T, how do we get rid of the 3 in the front? Very good. Multiply by a third. Same thing with both sides. Okay, so left side, 1 theta is 5 pi over 6. And then over the right side, 1 theta is 11. I'm sorry, 18. I lied. 5 pi over 18. And then the other side, 11 pi over 18. Are those the only two answers? No. What do you do now? Add your period. What was the period again?
Pi over 3.
Yeah. Can I, by the way, pi over 3, can I make that into denominator of 8? So I can just, what would that be in denominator of 8? Yeah, let's do that. It's so much easier. We just add 6 over 8, right, pi?
18.
18. Ooh, you're right. Thank you. So 6 pi over 18. So that means 5 pi over 18. Ooh, I keep missing that. 5 pi over 18 right there. Plus 6 over 18, what would we have? 11. Okay, so the next one is 11 pi over 18. But guys, that's like the same thing as the other side. Why?
Because there's 3 solutions total, and they're gonna, when you add them the same angle each time, it's enough like a triangle on the graph.
Yeah, tangent is like different from tangent and cotangent are the two functions that's slightly different. Can you see like the angle here are diagonally from each other? They're gonna bound to what? Repeat, right? Versus, can you see this right here? They're not diagonally from each other. From here to here, it's a different value versus from here to here. So tangent and cotangent, you don't have to use both answers. You just use one and either add or subtract, because tangent, the distance from one angle to the next, they are exactly the same. Okay, so we can just use one and keep adding or subtracting. Always make sure you verify that's from 0 to 2 pi. So if I use this side and keep adding, okay, what's the next one? 17 pi over 18. When can I stop? Before I get to 36 over 18, right? All right, keep on adding. What's next? 23 pi over 18. Can I add some more? Yeah, what's next? 29 pi over 18. Can I add some more? Yes, what's the next one? 35 over 18. Now I can stop because the next one will be over 2 pi, right? Oh, that looks like a boot. Sorry. I'm easily distracted. So we have to stop before 2 pi.
Why is the period 1 pi over 3 instead of 2 pi?
Because tangent and cotangent, remember tangent and cotangent, it repeats after every pi. So let me go back to back at the beginning of 7.1 when we graphed tangent, Chris. Give me a second. It's going to take me a second to move. Oh, actually, just even cotangent. See over here, cotangent? Can you see from 0 to pi it repeats? Yeah. That's why. Cotangent and tangent are both repeating after every pi. Okay, here we go. C, period. What do you think it is? 2 pi. Because do you see any number in front of theta? No. So period is 2 pi. So if it's 2 pi, do I need to worry about adding and subtracting? No, because it would immediately be over. All right, how do you solve for C? Bless you. Yeah, take the cosine inverse, you're right. Equals cosine inverse of 1. Where is cosine inverse of 1 at? 0? How come I can't use 2 pi?
Non-inclusive.
Because it's non-inclusive. Because in the instruction it said non-inclusive 2 pi. So you're right, this is immediately 0. So theta minus pi over 4 is immediately 0. Now I'm just going to solve for theta by adding pi over 4 to both sides. So final answer is just, that's right. All right, D. What do you think you want to do on G? What do you, yeah. What?
Factor.
You just dropped the F-bomb, Ruby? All right. You would need to factor. Okay. If you are not comfortable with cosine or sine or tangent, you can always let x be whatever that trig function is. In this case, the trig function is just happened to be cosine of theta. Okay. You can always take it out. You put x and then put it back in. So then that will give you 2x squared minus x minus 1 equals to 0. Why don't you do the factoring? And I'm just going to ask you to give this to me in a minute, okay? So factor it out, and then I'll call on you as you need the factors. And then you can go as far as you can. When you're done, compare the factors with your friends to make sure you're on the right track. Because if your factors are wrong, then your answers will be wrong. Grace, what are your two factors, huh?
2x plus 1 and x minus 1.
Do you guys agree? Okay. Now, do you want to put the cosine back in, or you want to put cosine back in later? Back in now? Okay, sure. Anytime. So 2 cosine of theta plus 1 times cosine of theta minus 1 equals to 0. What do you guys remember with each factor? What do you do?
Set it equal to 0.
You're right. Here we go. 2 cosine of theta plus 1 equals 0. Cosine of theta minus 1 equals to 0. On the left side, Ray, what do you want to do first?
The left side?
Yeah.
Subtract by 1.
Good. Subtract 1. And then after that, what do you want to do next, Ray?
Divide by 2.
Perfect. So cosine of theta equals negative 1/2. I know we have been using cosine inverse to both sides, but technically you are not even required to show that step. Would you agree that cosine of theta equals a negative 1/2? We would have two different places. What quadrants?
3 and 4.
I meant 2 and 3?
Or, so, yeah.
Yeah. So 2 and 3. Now we just need to know what angle in quad 2 will give me a cosine a negative 1/2. In quad 2? Yeah. 2 pi over? You're right. Okay. Then what angle in quad 4? I mean, not quad 4. Quad 3 is that?
4 pi.
Right. They have to be multiples of pi over 3. So that's that guy. So on the left side, we have two answers. Now on the right side, we're going to do the same thing. Move the 1 over. So you have cosine of theta equals a 1. You do not need to compose both sides by an inverse if you already know. Okay? That's just an extra step that if you don't know. Would you agree that cosine of theta is 1 is only at one place? And that angle is 0. So because the period is 2 pi, do I need to add or subtract anything? No. Let's just write those in order. Theta is 0 radians, 2 pi over 3 radians, and 4 pi over 3 radians. We have two examples left with solving by hand, and then we'll solve some by calculator. E and F. What do you think we need to do to solve E?
Substitute cosine squared with sine 1 minus sine squared.
Whoa. All right. So sounds like Michael's using this identity. Cosine square of some angle called theta plus sine square of some angle called theta equals 1. Okay. When you guys are solving, they have to be the same variable most of the time. So right now you got two sines on the cosine. It's probably easiest to substitute cosine. Would you guys agree? Yeah. So, oh, I did not mean to cross that out. So we want to take that out. If we take that out, that means we have to use our identity and solve for cosine squared. cosine square equals 1 minus sine square, and substitute that in. Okay, so we would have sine square of theta, we keep it, minus sine regular of theta equals 1 minus sine square of theta. What do you want to do next?
Move all from onto the left side.
Yep, move them all and make it equal to 0. So that means I'm going to subtract 1 and add sine square to make that whole thing 0. Add sine square, I'm going to line it up with the sine square on the left. Minus 1, I'm going to minus 1 right there. So that means this right side equals to 0. Okay, so 0 equals. How many sine square do we now have? 2. 2 sine square of theta minus sine of theta minus 1 equals to 0. What do you think you need to do here? The F word. Oh my goodness, Tim. All right, go ahead and back it up. If you want to use X for sine, would that be okay? Sure, whatever you're comfortable with. All right, Michael, what are your two factors, hon?
2 sine theta plus 1 and sine theta minus 1.
Thank you. Take each factor. We will set each factor equals to 0. So 2 sine of theta plus 1 equals to 0. Sine of theta minus 1 equals to 0. Similarly, Zen's not here. Chris E, on the left side, what do you want to do?
Left side,
Mm-hmm.
you want to subtract 1 and divide by 2.
Thank you, sir. Subtract 1 divided by 2. So sine of 1 theta equals negative 1 over 2. On the right side, Max, what do you want to do on the right side?
Move the 1 to the other side and then do, or you can just do that.
Okay, so now let's decide with angle. On the right side, since you're on it, what angle will give me a 1 for sine?
Pi over 4. Pi over 2.
Pi over 2. Sine of something on the left side is a negative half. So Alex, why? What quadrants will give us a negative for sine?
You can do 3 and 4.
Yes. Now we're going to find those angles, okay? What angle in quad 3 is that, Ruby?
I have no idea.
Consult your team. Think about it. So consult your team and then Ruby will give us an answer when she's ready.
Quad 3. Yeah, sounds right.
Thank you. And then Riley, what angle in quad 4 is that?
What was it? The first one was,
So Ruby gave me 7 pi over 6 in quad 3. Now we have to find the...
and then 11 pi.
Yes, ma'am. Very good. Guys, do we need to add or subtract anything? No, because the period is 2 pi. So let's just list it from smallest to biggest. We have an angle of pi over 2. We have an angle of 7 pi over 6. And then one last angle at 11 pi over 6. Okay, last one, I'm going to give you 2 minutes head start. Okay? So you and your team, work it out, please. Some of you have already done. Great. Once you have an answer, share with your friends. If you look at your friends and they don't know, if they haven't started or they are stuck, like, hey, Gene, no.
Oh, shoot.
If you're done done early, can you compare your answer to friend, please? If you're stuck, can you ask friend for a hint? Please.
Oh, yeah, okay. No, you should only end up with the square. Because you're gonna add sine squared to both sides. And then you get 4 sine squared equals 1. Subtract, yeah, and you get 4 sine squared of theta minus 1, 0.
So far you did great. Do you want to go?
Yeah, that's difference of squares. That's all that is.
What's the best factor?
By difference of squares. Oh, it's the same thing.
How many answers should we have? 4. We should have 4, okay? So, did you guys substitute cosine square or sine square? Okay. Does it matter, by the way?
No.
No, you get to choose, okay? So then I would just write that over. Cosine square is 1 minus sine square of theta, okay? Can I add sine squared to both sides? That will give me 4 sine square of theta equals 1. There are multiple ways you can go about this. You can factor it out because it's a difference of 2 squares. Or we can now divide both sides by 4, and that's a quarter. Then I can take a square root, right, y'all? If I take a square root, how many answers do I have? 2, because remember, it's a regular sign. I can have positive and negative. It's totally okay. Plus and minus, square root of 1 is? 1, square root of 4 is? 2. So either way, factor or non-factor, you will always get the same exact answer. Okay? So that's a pi over 6 here, 5 pi over 6 here, 7 pi over 6 here, and then last one is? Yeah, so I'll just write that in order. So write that in order in your notes. Okay. Now, our next example, it's going to be calculator required because it asks you to round to 2 decimal places. So go ahead and take out your calc. You don't have one, stretch your legs. Go and borrow one. With a calculator, if you already know how to solve using a calculator, you go for it, okay? Looks like some of you already have the answer to the first part. Don't go on to number 2, please. Just wait till the second part, okay? Let's review.
Wait, don't go to B.
Yeah, don't go to B. So we go. Example 2. Solve each, round to 2 decimal places, and again the same interval from 0 to 2 pi, non-inclusive of 2 pi. When you see rounding, just use your calculator right away, okay? On the first one, I saw that many of you just have one answer. Would you agree that there should be 2 total? Because isn't a regular cosine? Wouldn't a regular cosine is positive in quad 1 and quad 4? Okay. So you can do 2 ways. Let me draw out the angle for you. The first one, I think everyone has this one. What was this angle here based on your calculator? Thank you. Okay. Now there should be a second one here. If you solve it manually, how would I get there? Right? Well, if I had a pi, hun, I'm going to be over here.
You want to do 2 pi minus your answer.
Yes, you want to do 2 pi minus your answer. And then someone give me that one. Whatever that 2 pi minus 1.37. Joe.
Wouldn't it be in degree mode because we're solving theta?
Good question. It would still be in radians because your restriction is in radians. Very good question. So 2 pi take away 1.37. What is that?
4.9.
Okay, 9.1 you said? So these guys are the two answers. But better yet, I would like for you to do it this way so you don't miss anything. Go to y1 and y2. Okay? Find y1 and y2. We're going to solve by graphing so you don't miss those things again. Okay. y1, pick either the right side or the left side. As a class, what would you like to pick today? Cosine of x or 0.2? It's not a trick question. Just pick one. Thank you. So everyone on y1, tangent cosine of x. That means y2 would be the other side of the equation, which we now have to put in 0.2. Okay? Your window, x min, must be from, x min is where? 0. X max has to be 2 pi. Enter that in. And don't put in 2 times 3.14. Just do 2 and then pi. Then hit zoom fit. Can you see how many points of intersection your calculator shows? How many? 2. Go ahead and trace those intersections and tell me if it's the same as what we did by hand. If it's not the same, that means we graphed it wrong. So we need to go back and correct it. So was the first one matching up? Or you calculate it manually? Yeah? No? Okay, trace for the intersection. Okay, so what was the first one, say, on the calculator, on graphing? Still 1.37? And then the second one, is it still 4.9, what is it, 91 still? Okay. Can you see that graphing? You can see 2 points of intersection right away? Yeah, so you can solve either one. You just have to be mindful. Okay, why don't you be on your own? Probably graphing is best. So that way you can see. And I'm going to come around and help you with the graphing calculator. Do you need help?
Yeah, I just got you.
May I see your y equals? On the first one, okay. Window? 0, okay. Zoom fit? Did you do zoom and zoom fit? Are you in radians? Okay. Gerald, do you need help?
Yeah.
Okay.
So
Go to y equals.
This
Okay.
should be good.
And then
but
with
it was-
mode. Let me check your mode. Okay. Window 0 to 2 pi. Okay. Zoom fit.
Yeah, and do I just use this trace capability, or how do I calculate it?
Second trace, and we want to find the answers is when the two curves intersect. So go to intersect, and then go close to one of the dots, and then because it's asking you, do you want the first curve to be the cosine or the line? It doesn't matter. It will
So it should be
automatically.
like here?
And then it will jump immediately to the other one on its own. Hit enter.
Oh,
You don't have to. Yeah. Once you decide on the first curve, the second curve doesn't matter. So.
yeah.
Yeah, there you go. So 1.37 exactly, and do that again for the just for practice. Trace as in curve. May I see your equation very quickly? Okay, go to window. Your window. Okay, zoom fit. Your windows wait. Zoom and zoom fit. Once you, anytime that you put in your own x min, your own. Okay, now you can see better where they intersect. Okay, how do you trace for this first point of intersection? Second, cow. There you go. Go down to intersect. And then go close to it, because you got 2. It's going to be confusing if you're not going to go close. It doesn't matter. You pick one. Now, once you decide on the first curve, that's good. Once you decide on the first curve, it will automatically go to the second curve. You don't have to touch the second one. Just hit enter a couple times. See, 1.37. Practice on this side to make sure we're good. Anyone need help with calc? You guys are okay with calc? Okay.
Yeah, my calculator is
On B, what did you guys type in for y1? On it's the left side? Yeah. You guys just, it doesn't matter. There's not wrong or right or anything, okay? Now, make sure you only put parentheses on this dude, right? Okay. And then the other side is 4. How many answers did the calculator show? One. Did you trace that one?
Yes.
Great. Give me the answer. X is 4.53? Beautiful. And that is an egg roll for today.